लाइट कितना देता है? इसमें और कुछ सोचने लायक है? मैं तो अंधेरा अंधेरा देख रहा था। एक और लाइट है। इधर से। Good evening, everyone. I welcome you all of you on this online lecture series of NBC. Today's lecture is on structural design, timber and bamboo, which is covered under Part 6 of National Building Code 2016. So today's lecture will be delivered by Shri Amitva Sil. He is scientist and HoD of Kolkata Field Station, IWST, and he is also an expert panel member of NBC. So during the session, you can post your doubt in chat box so that you can take later. And I also want to inform that today's lecture is live on YouTube. So after lecture, you can visit if you miss any prominent parts. So I invite Amitava Silli to please share his slides and take the lectures.
Vivek. Okay. So just now I have to introduce or just I can start the presentation.
Yes, sir. Yes, sir. Yes, sir. You can go ahead.
Okay. Is it visible?
Yes, sir. Yes, sir.
Okay, good afternoon, everybody. So today's session will be National Building Code, where this is one section. It consists of 3A and 3B, timber and bamboo. So this is included in the National Building Code 2016, and it is also in the revised new form. A new revised part will also come. Okay. So now, what is a green building? So as you know that a green building is a type of building which is a type of building where all the materials are made environmentally attractive, and if you stay there or if you live there, there's no hazards or environmental impacts on our health. So that is categorized as a green building. So that is we should have a very minimum negative impacts on the environment. So first on the timber section 3A. Now, why we have choose this? Why timber has been chosen as one of the building material? Now, as we know that timber is a highly energy efficient material, and it is one of the best material which can significantly contribute to the greenhouse emission. During the constructions of building sectors, as we are using a lot of conventional material like cement, sand, coarse aggregate, and what they release a lot of carbon dioxide. So that is a much more the our concern of the our glow of our earth. So if we use timber, so at least one third of this energy is be reduced by timber, and also we can get lot of carbon footprints. Uh, we can also reduce the carbon footprints by using timber compared to conventional material like steel and concrete. As you know that this timber has a high enormous potential storage of carbon dioxide. So it is estimated zero point 0.9 tons of carbon dioxide is stored in every ton of wood. So that we want to that is very efficient as a useful for the building materials, but it doesn't release carbon dioxide. Moreover, this timber structures, if you build structures using timber, there are also good thermal insulation. This is a high good thermal property. Now you can see what are the panels available in our market, that is made of timber. One is plywood, one is particle board, board, laminated veneer lumber, blockwood, flush door. So these are all all have been used using timber in various parts, in various boards. When it is made into particles, we can make as a particle board. When it is made of wood particles, very fine particles, but it is highly densified, so we can get as a medium density fiber board. And it is a laminated veneer lumber. So it is one of the type of construction which is used for beams and columns. One is a flush door. So these are the various products from which this construction material can be used. Now we go for this minimum permissible stress, because when we use timber to design a structure, so we have to think of this. It's very much required. What is the minimum permissible stress required for timber? Now, timber available in India, I will show in the next slides. They have divided into grade 1 timber and grade 2 timber. So, and among them also, there are many groups they have categorized. It has been categorized in the National Building Code, Group A, Group B, Group C, for availability to different physical and mechanical properties. They has been divided and they have been categorized for the three groups. So these three groups, how they have categorized, the timber should be high moderate durability, they should have high or moderate durability. They should have low durability, and they should have proper treatment. If we treat the timber, that proper treatment can be done for the timber. So that is very much important, because treatment of physical treatment for timber is very much essential before it is being used, because a lot of quantity starch are there, and it is a very much infect for this termites and borers. So it should be treated before use, and the load should be continuous and permanent and not impact type. So that should be taken into account when design. So these type of things, based on the three things, these groups have been categorized. So these are the multiplying factors for purpose test. For grade 1 timber, 1.16 we have to multiply, and for grade 2 timber you have to multiply by 0.84. Now there are species will come in the next slides. So they has been the main mechanical property, that is static bending properties, that is MOE, modulus of elasticity, and extreme fiber stress, that is bending in FB. So these are the main two properties which we require during the design of the timber structures. So you can see in group A, E value is given to 12.6, and FB is extreme fiber stress at 18 MPa. So like this, group B, group C, all, so whatever timber you get in the next slides I will show, there the properties are given there. So you can now, if you test in the lab also, or else if you can get the values, you can categorize the material according to group A, group B, group C, and in that reason you can see whether this material is these values or not. Then you can design accordingly. You can see this is the your species. You can see on the left side, acacia, catu. These are all the available materials in India. What are the species available? So also you can see which area. So some species are also extinct and some are available there. Here you can see what are the values they have given: stress, compression, the grain, popular grain. This compressive strength. Here you have to calculate the strength grain and across the grain. And along the grain means along the ring, because every tree has a ring. There's annual growth ring, it is called. So if you cut the section along the ring, will be parallel to the grain, and if you cut across, it will be perpendicular to the grain. So you see the durability class is there, and this is treatability class also there. So these are the things you have to take care of. So you can see A, B, C, D, E, many treatability classes are there. So along that, you have to classify the materials along group A or group B. You can see the next slide. Group B is there. So the timber species are there. Many are there. So I'm not included here all the timber. It will be a lot of slides. So mainly that is you have to find which timber you want to take design. You can see the group C. All the species are available in this area, in this region. Now, These are the requirement for the minimum permissible stress for different groups of timber. So you can see along the bending, for bending stress, when it's for static bending or horizontal shear or anything. This is the values you can take in account for design. Group A, Group B, Group C, 18 MPa, 12 MPa, and 8.5 MPa. And shear strength, you can see along the grain or across the grain, both values are there. Compressive parallel to the grain and compression perpendicular to the grain, both the values are there. And modulus of elasticity, there is elastic strength. So it in MPa 12.6 for group A and 5.6 for group C. So these are the take care of during the design. After that, also this timber shall be indicated for bending strength, horizontal shear, and deflection also. See, this is a major thing. Here you have to calculate the bending strength. You can calculate the flexural strength also. So flexural strength, there is a formula. You have applied the formula where M is the moment of inertia and Z is the sectional modulus. So you have to calculate this formula. As you know, in the civil, we also studied this one. Formula is very much required. And here, this can be calculated on a load of beams which move from support towards the center of span. So here the load should be taken account from the support towards the center of the span. This type of load we have to taking account, and apply the load. It should be 4 times distance, 4 times the depth of the beam. What is the depth? And you have to multiply with it to 4 times, and at that point you have to apply the load. So on the basis of that, when you apply the load in a sample the timber section for testing, there you can after testing you can get the Fessenstein values. So deflections of the flexure beam, which are the if you use this brittle materials like gypsum ceilings and where you support the materials or the supporting materials. So here you can it should not exceed more than 1/360 of the span. So sometimes it's also not more than 1/240, and also for candles it should not be more than 1/20. So you calculate by this formula KWL cube by EI, where E is the moment of inertia of the joist, and EI is the moment of inertia of the timber section. So with this formula, you have to apply, you have to calculate this deflection. What is the maximum deflection? So there is the values are there. So when you design the beam, accordingly you can calculate whether the permit is permitted or it is not permitted. So there you can calculate. Then for the nails, arrangement of nails in the joints, it is very much important where to apply the nails, because the joint material, how to join the timber. So this is the so that to avoid the splitting, because splitting, yes. So we have to be careful when placing the nails along the timber for joints. So you can see the total requirements are given. For end distance, if we apply for tension or compression, it's 12 N on 10 N, and for edge distance, it will be 5 N. So N will be your shank diameter of the nail. 5 N the distance between the rows perpendicular to the grain. So this is the distance you have to calculate, and you have to apply in the where to apply the nails during the joints. Now there are two major parts of timber that is now it has been used. Previously it was not there. That is blue laminated beams. So it is, you can see the figure. So you can here the two types of blue laminated beams are there. One is vertical, one is the horizontal. So it is a type of structural engineering wood where different layers of wood are being jointed together, jointed together with the help of some adhesives, glue adhesives, so that they can become a single block, and all the timbers are dimensionally stable. So if we bond the layers along the grain, so it will be a perpendicular parallel to the vertically, or if we along the if we bond the this your layers of timber across, so it will be a this was again. So like this, you have to when is there. So here we can this type of beams. So it is a straight member, and we can you can see that we can arrange we can align the layers of timber, small layer, similar type of plywood. Plywood, the veneers are very thin, but here the thickness will be more. So similar construction can be done. So it and bonded together. So it is called a glue laminated beam. So we main thing now you can tell as a glue laminated timber, GLT or cross laminated timber. You can see this is a glue laminated timber. So it is a you can see the grains of the laminations runs parallel to the length of the timber. So this is the parallel length, and here you can see all the grains. So this is the glue laminated timber. You can see we can bend this timber according to the requirement curvature. So this is very much dimensional stable material used for your beam and columns. Another is that cross it is one is along the grain and another is across the grain. We can complete similar construction of the plywood. So it has very good dimensional stability properties because it can transfer load in 2 dimensions. It will be used for it is very much useful for wall panels and roofing materials, and it is suitable for earthquake zones also, and it has very good effect for charring effect in the fire. Means it does not when fire is caused or fire is created, fire is happened, the total fire does not get inside this timber, but it forms a charring effect. Means it will form a good layer so that the fire does not enter inside, go inside the this timber. So these are the tests which has been carried out on different timber species: rubber root, Melia dubia, silver oak, eucalyptus, radiata pine, and chalk pine. All are Indian timber. So on this timber, these bending properties, compression, block shear strength are being calculated. So this can be used for during design. If you use this material as in design, so we can use this value. This is a lab graded test. Then other is from the plantation timber. Other properties also we have calculated. This for Melia dubia, this Gerald robusta, rubber. So these are the 4-point bending test we are carrying out. We have carried out also. So these are the values, and these are also available in the National Building Code. Also, now it will come in the National Building Code. So this has been data we have incorporated. Now another major threat is the termite attack. So this is the very much required. I think it's wrong here. Its heading is wrong, I think. So actually, this is the main thing is the structural requirement. So mainly is the load bearing capacity. It can carry or it can take for the vertical lateral loads what is imposed on the building. Then is the cross-sectional dimension. What dimension of this two member, that is cross CLT and GLT, should be manufactured, should be calculated, should be made so that it can be used for construction. It also depend upon the building height, then occupancy and other things, and also how much design load we can design it and we can apply, and then we can find out the section of the timber. So for CLT, if we use cross-laminated timber in roofing panels or flooring, so there is minimum thickness of 100 mm should be there, not less than 100 mm. Reflection limits is telling that it should ensure the reflection limits under service load conditions within the acceptable limit of NBC. National Building Code, in other sections, it has been told. In other sections in concrete sections, it is all be told about the reflection limit. So that limit we have to follow for this timber section also. Now, when we apply hybrid system, means if we apply timber along with steel, concrete, or sometimes we are using bamboo also. So there also ensure the design load paths are continuous, and also the material, if we use concrete or timber or bamboo, they should be compatible to each other. Means if we use a particular timber, it may not be compatible with steel and concrete, but maybe other timber maybe. So you have to check the before applying. Load transfer mechanism should be accurately so that there is no failure at the connection points between the materials. So between this, means hybrid connections will be there. Hybrid materials, if you use hybrid materials, so hybrid connection will be there. So connections at that point of connection, it should not fail. So this should be taken care of during the design. So now this is the main part, how to protect the material, means timber and board. See, this is the major destroying elements which can destroy the total timber and timber and hardwood and softwood. They can totally destroy it. So more major part is the termites and beetles. So from the ground, actually you can found this type of materials which go inside the timber. There is a subterranean termites. They're the most destructive, and we should destroy it before using it. So control measures should be taken for the soil treatment also, and also for the timber also. So there are many treatment processes are there for treating the timber. Sometimes we also spray in the trench in the before applying there, and other is that your pressure treatment. So pressure treatment is there where you can treat the timber with some chemicals are there, that is CCB or ACC, copper sulfate, sodium and boric acid mixture is there. So there we can use this material and we can treat the material by keeping it in a vacuum chamber, and the chemicals go inside this with some retention of amount of 50 kg per meter cube. Next section will be your, so this is part 3B. Now lot of species available, bamboo species are available in India, but we have studied 100 species, and among that 20 species has been systematically tested. But among that also, among the 20 species, only 60 species are recommended for structural use, because the strength are very much less. You can, these are the species name: Dendrochloromus strictus, then Dendrochloromus hamiltoni, Bambusa tulda, Bambusa pallida. These many species are there. Bambusa balqua. But these species mainly are found in, you can see in the figure in the map, northeast of India. Bamboo cultivation is much more. Then Madhya Pradesh is coming, and then also some part Maharashtra is coming. So a lot of bamboos will be found in this area. All the species will be found, but there are some species we have tested, and that will be used for structural use. You can now see timber. For timber, we can do the grading, because grading of timber, though Indian code is not there, but some ISO codes, why we can grade the timber. So graded timber even available. But for bamboo, grading of bamboo is not available. It is a natural material, and we cannot grade simply like grading of timber. So here there are different material, different characteristics, properties by which we can grade bamboo. One is that diameter and the calm of the bamboo. How much taper is the bamboo? Then curvature. If it is a bent bamboo, how much curvature we have to calculate? The internodal strength of the bamboo, density and strength, it is your MOR, wall thickness, and durability and seasoning. So based on this, we can grade or sort the bamboo before use for different use. You can use bamboo for columns, walling systems. So here you have to grade accordingly. The minimum length of combs shall be 6 meter, and it should be, so 6 meter is available minimum length, and taper should not be more than 5.8 meter per length. So bamboo is actually taper material. In the bottom diameter of the bamboo more, but in the topmost portion diameter will be less. So this is the minimum criteria. You have to select those bamboos where the taper should not be more than 5.8 meter per length. Then maximum curvature should not be more than 75 mm for a length of 6 meters. That also taken, if the curvature is more, that bamboo cannot be used. So we have to think, or else we have to make it straight by some different applying some mechanical or some methods. So this is time consuming also. And wall thickness. Wall thickness of the bamboo should not be less than 8 mm. So that is also taken care of for structural purpose. Now, when bamboo has been tested in the laboratory and others, so these are the values you have obtained. Here, one thing is that the fibers of the this bamboo fibers of the bamboo, they run on the axis as the come. So that is why we are taking the advantage, the strength properties for using as a structural material. And all the fibers are bundled together, and they mainly provide the strength to the bamboo. They are very straight, and they are very straight, and also mainly is that this strength varies from species to species. So for different types of bamboo, different values are often there. Available values are there. So this is specific gravity average. I am telling for me for average of these 16 species. So it's range about from 0.5 to 0.65 and average weight 0.265 kg per meter. Then is the major part is the other part is the tensile strength. Here you can see bamboo fails in shear. So here to calculate strength, we have to calculate the static bending strength called modulus of rupture. So that values give the what is strength of bamboo. When the bamboo is dried, when the bamboo you cut bamboo that is not dried, so that is called green bamboo. So dry bamboo has much more strength than green bamboo. But you can see not dried bamboo not more than 5 years old. So before 5 years old and more than 4 to 5 years gap, the age of the bamboo, that bamboo should be taken into account for that bamboo should be tested. Tensile strength is very much I told you because this the advantage of the fibers which runs along the bamboo. So that gives the tensile strength of bamboo. That is 1400 to 2800 kg per centimeter square maximum. It has been calculated for this elastic properties of bamboo, that is static bending strength. It is also very ductile in nature. The modulus elasticity you can see 1.5 to 10 to the 5 kg per centimeter square. This is the values available for bamboo. Here you can see the different types of bamboo, species of bamboo available in India, what values has been touched, but all have been started in the laboratory scale. So mainly the structural very much useful bamboo is there, Bambusa balqua and Bambusa nutans and Bambusa tulda. So these are the very much these are the bamboos which are used for construction, that can be used for construction. These all the values are there. So you can use the bamboo properties of bamboo from this table and you can design accordingly. Now, bamboo also holds moisture. That is a very much important. So when you season we have to season the bamboo so that it should not take the moisture from the atmosphere after construction. Because then bending properties, then bending will come. So that you don't require because it will fail in the joints and other also. So it should be properly seasoned before use. So that is very much important. You can see the graph when the temperature is increasing, the dry indicates are decreasing. Means when you dry it, the moisture content decreases, but up to certain point, after all, it's called fiber saturation point, when the moisture went there. So that is very much required. That is called seasoning of bamboo is very much required. Now we go on the chemical treatment. Treatment of bamboo. Similar to we have to treat the bamboos also. Because bamboo is a natural material and it contains high quantity of starch inside it. So before use, we have to remove the starch. So there are many chemical methods are there, where it is short term and one is long term. Short term means cut the bamboo in the forest. At that time, immediately you cannot do the treatment process. Long term treatments cannot be followed because you have to carry the material to some workshop or somewhere said where you can give a treatment. So immediately there you can apply the short term treatment method called spraying or dipping or brushing you can make before loading the material in the transportation to other places. Here you can see the statement of bamboo. It is green or dry, and it is mainly important part you have to care of that when the bamboo should not have direct contact with the soil. So that is you have to take avoid. it will be directly infest on the this primaries and borers. A short time treatment is, you can see the prophylactic treatment. You can immediate treatment. Then under water storage, you can keep the bamboos under storage under pond for 4 weeks so that the starch leaches away. And some chemical treatment, that is sodium pentachlorate and other boric acid, you can make some solution and you can apply with a dipping solution. Other are that hot and cold, dip diffusion, internal injection, butchery, and vacuum process. So these are the many processes. Whatever need. The first, when you use bamboo, round bamboo for in a site. So first of all, those bamboos which are used as the columns, that should be given hot and cold treatment. It is mandatory. You have to give the hot and cold treatment. Because the bottom part of bamboo, which is going in below the plinth in the underground through a pit. So there you have to give this type of hot and cold treatment. So it is consists a drum where pressure oil are there, and you have to put fire below so that for half an hour you can give the fire so that this crescent oil in the right side you can see the figure in green color. You can see the crescent oil will increase the volume, will go up, and it will in the bottom part will be fully treated, and it will be penetrate inside the bamboo. So these are very much important, which when bamboos are used for outdoor. Next is a very important. There is a different deep diffusion method, because in the site also you can make some chamber and you can totally diffuse the dip the material fully submerged inside a tank consisting of boric acid and borax, 1% in the water. And also you have to make the hole, because it is pipe, but there are some nodes. In the nodes, and nodes, what has happened? There is a joint, so that in the internode, another internode, there is no connection. So if you don't make a hole, how the preservative will go inside? Every node point make a hole so that the preservation solution can go inside. This bamboo is stored for the tank for 2 days, and then you can remove outside and put it aside. Here you can see another method. The columns bottom portion you have got hot and cold treatment, hot treatment, and the above part which is going above plinth level, there we have to give the interlodge injection treatment. So here this interlodge injection, some chemicals like crescent oil or any other oil, like mainly crescent oil, you can put inside this inside the internode so that it gets penetrated, and you can keep the bamboos horizontally and roll 3 times a day for 7 days. And the treatment is a butchery process where this treatment can be done. Number of bamboos can be treated through a pressure tank uh, by this vacuum pressure. This is called butchery process. The pressure should be 1 to 1.4 kg per centimeter square. So you can use at a time. This is the part fire resistance to fire. This is the main major part also. Though bamboo contains high this epidermal layer contains, then also you can go for this treatment for fire. This you can put ammonium sulfate, ammonium phosphate, copper sulfate, water, and so this is the 100 parts. Among the 100 parts, you can use this part of if it is 100 kg of material, so you can add this type of chemicals inside it and make a medicine, and you can give a pressure treatment or hot and cold or dipping treatment. So this is the properties of structural properties of timber. We have studied. We have got some values. So this is the modulus of rupture. It lies between 50 to 70 for grade A, grade B, grade C. You can make which bamboos this modulus of rupture are more. And now one thing should be clear. One species called Bambusa balqua. This is available in many parts of India. But if we test that, it will give some different values. Here you can categorize group A, group B, group C accordingly. So in this method, we can use by laboratory test, the values have been there. So you can grade it A, B, C. So if you design the structures accordingly, so if you need a group A or group B, group C, so you can take this type of values from here. Then ultimate stress for bamboo will be determined as set 7.4, and you can divide factor of is given there in the bottom. You can see the model for modulus of the city. You can divide the stress factors by 4.5. For composite strength parallel, you can divide the factors of 3.5. So what are the values you will get? You can divide it. So that you working stress. For change of duration other than load, the pharmacist stress shall be multiplied by these factors. So you can see these factors have to multiply to get the ultimate permissible stresses. Now the shape of permissible stress and the structure of bamboo permissible stress available. So for group A, now we can see we have defined which species of bamboo comes under group B, group B, group. So Bambusha granicis and Dendrochlomus strictus and Oxygenus abensia. But mainly we are using group B category, which is largely available in India and now many parts. So Balukwanu, here we can directly take the values from there and we can just design it. Now mainly the design considerations. So while designing, so these are the critical things we have to take into consider. So with acceptable probability, it should be fit for use. When you should design which is used, which should be fit, it should be a simple design with appropriate probability of reliability, so that it will sustain all the forces like wind load, earthquake load, all the loads it should sustain. So we should design with appropriate probability reliability. Structure should be properly maintained. Getting the material from natural material, so it should be properly maintained also. Some maintenance, constant maintenance should be done all on the on this bamboo or timber. So structure should be according to design limit. Loads shall be according, since there is no specific design criteria for this earthquakes. We can take IS 1875. This wind load. Also, we have to take care of the wash because it is a natural material and it is a hollow also material. These are other things you have to consider, because using the structural components, because you can use bamboo as a column or the truss, purlins, rafters, anything we can say. So during this, you should consider these following materials. So the elastic bamboo of behavior of bamboo until, so it should not consist as a plastic failure, but we should consider the elastic failure. So if we design, it should go as a tube structure, hollow tube material of the mean diameter, because it is taper material, and also we can take the mean wall thickness, one in bottom, one in top, and one in middle. So, three things we can take, and we can take the mean values. Then we should not take where the nodes, we can take the material where the internode is more, so that nodes should not come, the internode distance should not be less, should not be very less. So we shall design the joints along the nodes where the nodes are there. So we can apply the joints. The joints will actually hold the structures. That is that of this when designing bamboo structures. So we can use some conventional structure analysis, apply this conventional structure analysis for design of bamboo structures by using these values. Joints as a hinge or pin. So that is very simple thing we can have to take care of. Now the flexural members can be designed by using a principal beam theory. So we have to calculate the I, that is moment of inertia, and the outer diameter and wall thickness shall be measured. So we have to measure both the outer diameter, inner diameter, and the wall thickness, both the ends, because it is taper length. So we have to both sides. In value, we can calculate the moment of inertia. So maximum stress shall be calculated, should be within the allowable stress, that I know, so that you know, because it is designed. The shear stress in neutral layer at the small sense is checked, and if the length of the beam is 25 times the diameter of the end. So if the length of the beam, when you're designing the length of the beam is 25 times the diameter of that bamboo, then we have to calculate the shear strength in a neutral layer. So that should be very much required. For columns, columns is the main part that transports from beam to this foundation. So for the columns, you can apply the two criteria. For a buckling test, this is calculation done on the, you can calculate on the moment of inertia, or from bamboo columns, best available straight bamboo. This can be selected, I told. So here you have to select the straight bamboo, not a bended bamboo, with a miniature, very less amount of curvature. Bending stress is with initial curvature, eccentricities, induced reflexes shall also be taken about. So if curvature is there, because at 100% you cannot get a straight bamboo. So if the curvature is there, so you have to calculate the eccentricities and bending stresses due to this curvature. So by using the Euler formula, so we can buckling, and we can use that 90% reduction of inertia. Also, sometimes we are using not a single bamboo, means single round bamboo, club bamboo, 4 or 5 tied together to form a single bamboo. So here the strength is increased, and all other properties gets reduced. So this is very much important. You can use the bundling of columns, or bundling of bamboos as a single column. You can see now how they are joining. Joining is a major part in bamboo connections, because you cannot weld, you cannot do nothing here. So these are the many options. You can join bamboo by full left, half left, splice joint, by inserting some wooden materials inserts between the bamboo, then hub. So this is the many process how you can join. The joining is very much required for, because if you want to increase the length of the beam, then joining is, you can see here the joints can be done inside. Plug is there. So many types of joints are available here. So if we use this tapered type wooden plug, here the joints can be there with the nuts and bolts. So bamboo column, you can see the node. So I told you the nodes. Before that node, we can use this type joints. Also, we can do this type joints also. So this is a very types of joints. Then for this truss material, so this also you can use this similar to steel pipes, steel connections. Here the you can use structural plywood, 6 mm thick structural plywood, or 6 mm thick uh, bamboo mat board. Previously we used to use soldering gate plywood, but now we have to use structural and or 6 mm thick bamboo mat board. So this type of material you can use for this. You have to calculate the shear strength also. Now I'll go through you a very small design which is available in the National Building Code also, how to use earthquake using bamboo. Here you can see for the earthquake structure, the columns, column is going inside the footing, it is foundation. Very less amount of footing foundation is required, and that is only 2.5 feet length. So that is a maximum we can go beyond. Maximum we can go beyond plinth. Anchoring part, anchoring part where you can anchor and the pit can be covered with the concrete. You can see here. There are also other process we can make the column foundation. This arch type also can be done. Here you can see there is very small footing where this bamboo can be inserted. Here this chemical solutions, their soil to be treated chemically, and these are the two available chemical in the IS as per IS 894. This chloropyrifos and imidacloroprid. Two solutions can be used with different proportions before putting the bamboo on above it. So this is the very much required, so that this connection between, if something concrete get damaged or anything, then the termites can again come inside. That using these chemicals. The footing size is very much less. It can be done through bricks, or you can see this is the bamboo. You can see the diagram where it is showing the wall thickness of the bamboo. Here, wall thickness should be minimum 10 to 12 mm. I told not less than 8 mm, more than 8 mm is normally available. And diameter of the bamboo should be 80 to 100 mm. So for these columns, we are giving hot and cold and also intranodal injection treatment. You can see the columns are inserted through a plumb blob and verticality is maintained, and then after that you can do the concreting. So this architectural structure here is the griding of bamboo is very much required. So there is a grid using the split bamboo. You can see the bamboo split in many parts. So the width of the bamboo will be 19 mm and thickness will be a thickness. So bamboo will be there, and grid you have to make 150 by 150 mm. This grid is very much required, which can sustain the earthquake. And we can apply this mortar on that without nothing. We can apply the mortar by without through a chicken mesh. You can see this mortar has been applied. The grid is made chicken mesh, and it should be done on the epidermal layer. Okay. So before that, this walls has been tested also against the shock resistance text. That is heavy impact and low impact force will be applied on the wall. Then raking test on the joints. Then for the roofing material, some test has been carried out on the bending, how much it can carry the bending force, bending load. Then for the fire, the roofing materials, and then this is a truss. This truss is made of bamboo. So this already 16 feet length truss is available. So these are the truss, and testing has been carried out. How much load it take. Basic is fresh bamboo should not be cut because should not be used. It should be matured bamboo should be used, and fresh bamboo, if cut, it should be stored there so that the moisture inside should end up. So not less than bamboo 3 years. Age of bamboo should not be less than 3 years. Maximum 4 to 6 years. We get it back. So 5 years is very much essential. And the connections, nails and should be avoided, must be avoided in connections because it will split if we use the nails. So prefer connection is the bolting or other screwing. Next is the maintenance. I told you. So this is a major part if you construct the house structure using bamboo or timber. So maintenance is very much required. So that this infestation does not arise. So there is many purposes we have given to maintain flagging concrete. You have to put then periodic check of the termites and borers. So you can make a hole at the bottom of the column, and you can check whether termites have come. After checking, you can seal the hole with a wax. So these are the things. Then you can apply some phytate chemicals available on the process, and then you can use share cardinal based transparent materials which is not hazardous. So these materials can be painted here. Bamboo with other materials you can use as a your web beam, then your straightened span for trusses. You can use it. So here the gusset plate and other material we can use bamboo mat board, and you can use these timber sections also for making these wooden flange and box type girders. Anything you can make with this bamboo and timber and bamboo mat board. Now coming to another part is the bamboo reinforced concrete. So this is a very new item which has been included in the National Building Code. It is not there in this 2016, but I'm just giving you an idea of what we want to put there in the National Building Code. So that is a study carried out using 2.5 years, 3 years bamboo. Three species has been studied: Bambusa balqua, tulda, and notans, and they have divided three parts: top, bottom, and middle. So you can see the best bamboo is the Bambusa balqua, which is very suitable for the bamboo reinforced concrete, as according to the study. CO stances, though be in other tulda and notans, but also it is very much important for, I mean, it has surpassed all the tests. Now, for this bamboo preservation or reinforcement concrete, treatment should be here also. Treatment is very much important. So, to treat the bamboo by using 5% concentration of boric acid solution as per IS 9096. This IS tells about the preservative treatment of bamboo. So after 14 days of soaking, you can soak that is deep diffusion treatment. So we can achieve this your PVC treatment, and then after that we have to take care that the moisture levels should be within 9 to 13%. Then we have to make this reinforcement details. So this is the bamboo as a stirrups, thin bamboo stirrups, and main bamboo is 80 to 100 bamboo we can take as a bamboo as a main reinforcement. So it is a better alternate to the reinforcement. Now you can see it is in the national building code what is given. The tensile strength catches of mild steel, bamboo, and concrete. So all the properties you have seen use this bamboo using steel or mass concrete. You can see what are the difference you can get. So this has been properties reported with different species of bamboo. You can see the direct ultimate strength of some species of bamboo is nearly same that of steel at its yield point. So it is very much comparable to steel. So that is why we can use bamboo as material. Bamboo tensile strength to specific weight ratio is approximately 6 times more than that of steel. So that is also another advantage. We can use bamboo in replacing steel in reinforced concrete. But major defect is that bamboo is a natural material, so it also deteriorates. So that is also we have to take care of this material when you're using it as a reinforcement. So we can see how we can make the reinforcement uh, in the concrete. So along the grain, across the grain, how we can put the strips of bamboo. So this same connection can be tied with a steel wire, and this bottom part. This is the bottom reinforcement part. So we can use this stirrups, these bamboo strips. Now we can see this is reinforcement for a. This actually the whole study is on the flexural beam, bamboo using bamboo as in a flexural beam. So this study has been done it. So here in the tensile reinforcement, this bamboo takes the tension while the concrete that you know concrete take the compression. So when you replace bamboo in place of steel, these are the main factors which governs. There is a tensile strength of bamboo. So tensile strength of bamboo is 200 to 300 MPa as you have seen earlier. Mainly another difficulty is the bamboo. The outer surface of the bamboo is very smooth. Epitaxial layer is very smooth. So how can we bond with the concrete? So some bonding arrangements have to be done. Means the bamboo outer portion can be sanded, and some spray can be done with some epoxy material, and we can again spray sand so that it makes the surface of the bamboo becomes rough. So another part is that also we can put some coating because bamboo over long duration can give some can can be affected by some biological degrades like termites and borers sometimes, or fungus. So that is, we have to give some protective coatings on the bamboo so that this outside moisture should not insert inside this part through water. The flexible capacity of bamboo reinforced concrete is also affected by the tensile strength, and therefore it is very much this very much governs this the ability to bond with the concrete. So the flexural strength of bamboo is high. That is why we can bond easily with the concrete. Now I can say what is the properties we can take. Bamboo strips width will be 18 to 924, thickness 7. This is the coating we have applied Sika 32 LP gel on the strips so that this avoids this your natural pests, so that they cannot attack this bamboo. And M20 grade of concrete has been designed. After that, this is the bond stress we have calculated. So before designing the BRC, bamboo and for concrete, we should characterize the tensile properties of the particular bamboo species in this beam. That is the variables you can see, the tensile modulus, Poisson ratio, then nodes, where the nodes are there. The nodes is also very much important, and slip. Slip is the major part which falls with during the bonding with the concrete. So slip also we have to taking care during this concreting. Now the different sections of bamboo strips. One is node and then the internal. So node, the tensile property is very less, and the tensile model. So node has very less tensile strength. So it fails there actually. So you will mainly make maximum use of this internode portion for design and other uses. So these are the textile properties of bamboo. You can see we have developed some formula. So you can get you can take the results, the bond strength 2.4 MPa. Here this tensile modulus is calculated on these are the different areas we have used. There is your LFRD method. So if we use this, apply this method. So this is what are the values we will take. That values were given in the previous slides. So tensile strength for design purpose can be taken as the FB. The bond properties with the concrete also depends upon the load displacement failure. So here we have to mainly taken care of the slip during the bond properties, because slip may reduce the strength. So for the flexible capacity, it depends on the concrete composite strength, because you are using M20, then it will majorly depend upon the concrete strength of the concrete, the yield strength, and also the bamboo reinforcement area. What are the percentage? What are the maximum percentage of bamboo you are using as a reinforcement? That is also very much important, and the effective depth. So here within this design, you can increase the length of the bamboo and depth of the bamboo. Also here the quantity of bamboo will increase. So depth of neutral axis is calculated on the linear strength profile, and it is 0.002 in concrete. Then other structural forces, this is not much required. Now we can see this is the flexural properties capacity of bamboo reinforced concrete by using this elastic beam theory. So it depends upon the BRC, means bamboo reinforcement, mainly depends upon the composite strength of concrete. What composite strength you are attending, you want to attend, yield strength of bamboo, then the dimensions means width and depth of the bamboo, area of reinforcement, and the depth is common. So partial safety factor depend upon the uses. You can use 1.45, 1.55, or 1.75, but target reliability you can take 2.5. Generally, you can take 2.5. So because you can use where it is not major load bearing properties, you can use this type of flexural beams. So you can see the reliability indices for BRC beams with percentage 1.5, 2.5, 3.7 are found to be. These are the reliability indices we have calculated. without any safety factor. So with this reliability indices, we can use the safety factor of 2.5 or 3 or 3.5, and designer can choose any one of the three according to the needs or requirement. Next is the dismountable bamboo shelter for disaster relief. This is also under research. So as per the government of India, this is the categorization of the disaster mitigation. So whether earthquake will be low, wind will be medium or high flat, these are the color. Here you can see this type of materials means all the elements should be have can be, it is all actually prefabricated. Means all are dismountable. It should be dismantleable. It should be reacted at site. So these are the three parts of the element of the structure for a disaster management. Now we have analyzed also through this software where applied different loads, dead load, wind load, many other combinations on the any bamboo structure. You can see how the wind load is applying this dead load, that the walls, and also live load we have calculated. You can see in a structure, we have seen the very less amount of displacement at the joints has been noticed. So you can see if we design bamboo, if we construct structure using bamboo, by taking care of all the limiting properties, their connections, so it will be structurally stable, and it is very much efficient for earthquake also. Now there is a standardization committee, CD 13 is also there, where this building, this bamboo and timber is being it being taken into account. And this is the structural design using bamboo. This is the code of practice 15912. The details are there. So it is also on the revision way, also on the revision. And this 3B and 3A, it is included in National Building Code, and it will be revised very soon already. Some new parts has been entered, has been included there. And another is IS 22156. It is a limited design, and also applies the use of bamboo structure. So we also next in the when we will revise this 15912, this IS 22156 and 22156 will take into account to revise this standard. So this is the you can see the bamboo has immense potential for innovative structures. So it could be used for mass housing, farmhouse, school building, disaster management, earthquake areas. So in the highly hilly areas, it is better to construct the houses with bamboo. And mainly if you construct with the prefabricated, it will be well and good because it carries very less load and bamboo absorbs the earthquake force. So that is very much efficient for this. And now I think the zones has been revised, has been upgraded. So zone 6 has come. So it is very much now efficient. All the fatalities occurs this in now in current recent years. So to tackle that, we have to think of to construct structures using bamboo and timber. Here, the NGOs and government or other work peoples can look up the PWDs and CWDs people who are working the engineers. They can very use this bamboo in the housing part. Thank you.
Thank you, Sil sir, for sharing such invaluable insights about the structural importance of timber and bamboo in the construction industry. We can get a clear glimpse of your expertise throughout this lecture. As we already know, bamboo and timber are indeed the ancient and best approach towards a sustainable infrastructure development if used correctly. So I hope this lecture
Yes.
helps. This lecture helps the industry professional to make the sustainability. So I invite participants if they have any doubt, they can go ahead and ask. Okay, yeah, no doubt. So once again, I thank Sil sir, and I also thank the participants for actively participating and making this online lecture series successful. And this is our fifth lecture. So our So if anyone has missed the remaining fourth lecture, I am to inform you that this is available in YouTube channel. So you can go through the YouTube channel of BIS and you can get benefited from that also. And if you get any queries, you can drop to our chat box or you can mail us directly to ced46@bis.gov.in. And I hope that our next lecture will be on 14th December, next Friday. That will be on structural design, concrete. I hope we will be again meet. And I once again thank you again, everyone, and have a
Thank you.
wonderful.
Thank you.
Thank you.
Thank you.